Hi, welcome to What's New in SolidCAM. In this video, we will see what's new in SolidCAM in the area of new applications. In the new version of SolidCAM, we launched what we call as an edge breaking cycle. Edge breaking is basically deburring of all the edges after a part has been completely machined. This is done generally to blunt the edges or to remove the burrs that have been formed during the machining process. Edge breaking can be done by 3-axis, edge breaking can be done in 4-axis, edge breaking can be done in 3+2 or minimum tilting, or edge breaking can be done in full simultaneous 5-axis. Let's look at the 3-axis edge breaking process. In the edge breaking cycle, all you need to define is the target. You need to define your start and end points. Also, you need to define the tool that's going to be used for breaking the edges or deburring the edges. And the tool that we are going to use here is a 5 diameter ball nose tool. This is how the tool looks like. The tools that are supported for edge breaking are ball nose and lollipop cutters. In the toolpath parameters, all we need to define is what is the width of the chamfer or width of the edge break that you would need. In this case, we have defined 0.2 millimeters, a constant width, or you could have a constant depth. You can define either one of these. And the edges can be detected automatically by SolidCAM, or the user can manually define these edges for deburring. I've selected the auto detect and I'm going to save the operation, and let's calculate this operation. Okay, the operation has been calculated and the toolpath is in front of us. Let's simulate this operation in Solid Verify. I'm using Solid Verify because I can show you the edges after it has been deburred using this tool. So let's run the simulation. You can see only those edges are being machined that are possible by using the current tool and holder definitions. The holder is coming into play, and wherever the holder is about to collide, the toolpath is stopped. So this is how the edge breaking looks like. You can see that all the edges possible with this current tool and holder setup is deburred. You can see that it's not completely done because otherwise it would have meant that the holder collision would have happened here. So only the length and area that is possible by the current holder and the tool is being machined automatically. The special care has been taken here to avoid collisions into the corner by stopping much before the corners. If he had gone more, it would have collided and removed this corner. So the corner collisions are automatically taken care in this new process. Thank you very much for watching this video.